Um, so it was, I said on the little blurb about this that it's also a shameless plug for the class that I'll be teaching along with Jerry Robinson, winter term. So that information is up there. And let me just say that this is going to be like a 10,000-foot flyover. There is so much with R that I couldn't even begin. So I probably have like twice as many slides as I need to. Hopefully when I kind of see what your interests are, then I'll know a little bit more about how to focus this. But let me just tell you from the beginning, there's so much more than I can even scratch. Okay, so you all came to BYU. You might remember back the first time you came here, and you can see here that this is a stadium, so the campus is back here, but there's a whole world outside of the campus to explore, and also the campus as well. So imagine that you're here for the first time, and you also, besides our campus community, there's beautiful things and interesting things to explore all over. So how are you going to do that? Well, there's one solution. You can get a bus pass. You can memorize where the bus stops are, where it goes, how to get there, what time it goes, so forth, and ride the bus. Or, how about if I said, there is an alternative to that. I could give you a four-wheel drive SUV with a mountain bike and a kayak and a sea-doo and a ski-doo and whatever kind of equipment that you'd like to explore those beautiful areas. Which one would you choose? Oh, one other little detail. This one costs money. In fact, it costs money every year you use it. But this is free. So again, which one would you choose? Okay. You choose the bus. Some people would choose the bus, and that's fine. But all those bus riders, that's great. I'm glad the bus is there, right? But this is an analogy for R. This isn't, I didn't come up with this. But programs like SPSS or other statistical programs that are point and click, they're basically the buses. They can do certain things. You have to learn where the stops are, where to point, where to click, what they do, so forth, and you can use that system. And you can use it for standard things, but if you want to do something a little bit different, it's going to be frustrating. But R, the programming language R, is like four-wheel drive SUV, and plus all the gear. And it can take you anywhere you want to go, but here's the catch: if you take time to learn how to use the equipment, okay? But let's say that I gave you those options. Is it fun to learn how to use a kayak, a mountain bike? I think it is. Okay, so same thing, you still have to learn to use that equipment. Okay, and so the one thing that I like about R is instead of just pointing and clicking and saying, I get this out and this is what I have to do for my assignment, I really have to stop and think. I have to put the steps together and say, okay, what do I want? This is where I start, and so forth. And then I can redo it. So there's a lot of different jokes about R, right? The pirates, R, R, R. And this is kind of how you feel sometimes when you're learning R too. And so, full disclosure, there is a learning curve, but R makes that easy to plot. Okay, so here's a bunch of boring stuff about the history of R, but I thought this would be better. There's a guy that's done, I think about 100. He calls them tutorials because they're 2 minutes long. A whole list of R tutorials, and he's pretty entertaining too. So. I have to say, I don't agree with everything he says here, but it's...
I'm going to teach you R.
I'm just kidding, I don't talk like that. Hi, I'm Anthony. I'm outside of the United States Capitol. Hey look, it's the Lincoln Memorial. We're outside the White House the night Barack Obama won re-election, but all I can think about is R. What is R anyway? R is like a duck-billed platypus, or an amphibious all-terrain vehicle, or a Swiss Army knife. Statistical languages, SAS, SPSS, Sudan, Stata. Programming languages, Ruby, Python, Java, C++. Statistical programming languages, just R.
This is R. Isn't it beautiful? Welcome to statistical programming. What's the difference between general programming and statistical programming? In general programming, you want a computer to do things for you. In statistical programming, you want a computer to learn things for you. What's the difference between other statistical languages and statistical programming with R? Other statistical languages don't lend themselves to automation. If you want to run the same commands over and over again, I hope you like pointing and clicking. R works based on the principles of computer science, so it's a much more flexible tool for dealing with today's data deluge. But don't worry about that. All you need to know is that R is the language of statistics. The lingua statistica, s'il vous plaît. Sorry, we didn't formally meet. What's your name?
Well, it's great to meet you. Insert your name here. Let me tell you my story. I learned R from two professors in graduate school. One examines MRI data, and the other looks at the effects of the environment on health. I use R for census, survey, and demographic data. You can use R for physics, economics, finance, genetics, and biology. Hey, R can even order you a pizza. Leave it alone. When you're ready to take the plunge, I'm asking you to hold your breath for at least the first 50 videos. You're going to have to trust me and make a time investment. R will not give you instant gratification.
You can have your own copy of R for just 5 easy payments of $0. But wait, there's more. If you download now, we'll slash the price, and you can have it for absolutely nothing. R is free. We're actually giving it away. Call now. Arithmetic and logical operators are standing by.
This has been a work of R.
So, that's a brief introduction. What? I wish I could talk as fast as he does.
I just said, sounds like he's a graduate student with too much time on his hands. Because he automated everything.
Yeah, exactly. He has time because, R did that for him. One thing that's interesting about R, when you think about it, it's peer-reviewed software because there's packages and libraries that you can load. They're all free, and there's thousands of people that use them, and you can actually see the code. So if you did some analysis in SPSS, you probably couldn't tell me, even if you wanted to know exactly the algorithm they used or how they did that. However, in R, you can see everything. It's open source, and you can see exactly what's been done. Also, let's say that there's some new way to analyze things or something new. Back to the bus stop analogy, what do you think the process is or the response time in getting that new implemented in SPSS or STAT or whatever? It's going to take a while. But if it's being done, you can guarantee that there's somebody that's doing it in R. And so there's just a lot more, things that you can do with it, but there's a lot more peer review and different kinds of things going on. So the one thing that I want you to take away is that when you think of R, you'll think of this statistical analysis, and if you're into that, it's wonderful, it's great. It can do almost everything that your normal SPSS packages can do. In fact, I don't know of anything it can't do. I've heard that SEM is not great at SEM, but you can write your own too. But that's just one part of it, okay? There's also, it has great visualizations, and you can run simulations in it, and one of the things that we should all be really interested in is the reproducible research, or reproducible analysis. And it's reproducible in several ways, but we'll get to that. So, number one, statistical analysis. There's so many things you can do. I can't even cover it. There's one thing, though. There's a psych package that's really awesome, and I just wanted to show you some of the stuff in it. If I can bring it up. This is just one package, and most things use other packages, so packages include other packages. But this is just one little thing. And the other thing that's great is there's all this free and open learning materials out there too. You can easily teach yourself. But if you need a kickstart, hey, let's just look at, oh, I don't know, there's so much here. So this professor who wrote this, he teaches the statistics class, but he does it all with R. And so we'll just kind of see what's, so here he's got, this is a visualization, here he's got 9 cognitive variables from Thurstone, and this is a correlation visualization there. And he shows how to do this all in R too, so it's pretty cool. This is a circumflex plot, I don't know if you know about that, but there's all these variables, and it kind of shows the strength of those variables. Some other stuff in here. This is,
So is the interface to R a programmer's interface, or is it a graphical user interface?
so that's the one thing that I'll show you. It used to be really primitive, like you had, it was kind of like a command line interface, which was really hard for a lot of people, but now there's an IDE.
Integrated development environment.
Thank you. I just think that that's the word and I forget what it stands for. It's called RStudio. It's also free, and I'll be showing you stuff in that today. And it makes things a lot more user-friendly. So this is just to let you know there's a lot of stuff out there statistically. But I would imagine that not everyone in this group is really, that's not like their #1 reason that they would use this. So the next thing is the visualizations. So it's not just your basic box plot and so forth and so on. There's some really cool things you can do. This is a correlation matrix that, here you see all the variables, and here's their correlation. Obviously these are all positive, perfect correlations because they're correlated with each other. But the blue ones are positive correlations, the red ones are negative correlation, and the width of them tells how correlated they are. The skinnier they are, the more correlated they are. I think I'll go here first. So this site has just a bunch of different visualizations that the people who do R have contributed. And the cool thing is about this is that you can look at one, for example this one if you wanted to see how to do it, and then you can bring up the code that how they made that visualization. So you don't have to think of it all yourself. There's lots of examples out there. And this, oh wow, okay. So here is the IDE, and you have your several panes. This this pane right here, it has your code, your source files. This is kind of a console where you get a lot of the results. This is tabbed, so in this pane you have files, you have plots. These are your packages, so you can easily load and the different libraries or packages. And this is really cool. This is a lot better than just the command line interface. So you can actually see what you have in memory. So here I have a matrix. It looks like 100 by 5. So you can examine it right here, which is pretty cool. And also any variables that you're using in your programming, you can examine here as well.
Can you enter data there? If you go back to your spreadsheet version of that, you can actually enter data this way in R in like a spreadsheet form, because you can't use R in RStudio.
You can actually change
Do I have to,
values,
CSV?
but I don't think they've done this yet. No,
Okay.
they haven't. Someday. Actually, there's a way to, I ironic thing is there's a way in the command line interface to do that. But
Chickens too, who can do the fun.
Yeah.
Oh, yeah.
If I gotta say if they.
in fact, you can take an Excel file, you can copy it, and then you can use a command that pastes it right into your R environment. And I do that when I want to do something really quickly. It's not great when you're doing it all the time, so after I've done it a couple times, just gotten it in, you can then write that to a file that R then reads in, or you can just put a line to read in the CSV file or whatever that she brought it from. So,
And you're guaranteed to get any level of significance that you want.
Really?
By adjusting that data. It's very useful. Yeah. So, data correct function.
but here's the thing: is when you publish your research, you can bundle up whatever code that you used and give it to somebody else, and they can reproduce it because they're using the exact same code.
Mary, you've got now you say that's the program code over there, 1 through 11. Could you just run us briefly through what it's doing? Because
Sure.
it doesn't look as complicated as some code that I've seen.
Well, and this is something that was written by somebody else, and it's statistical stuff, but there's much simpler stuff than that. I mean, I read about one professor, and she started using it just because one day she found herself without a calculator, and she needed one, and so she said, well, I've got R, I'll just use R. And so she brought it up and started using it as a calculator, and it just, one thing led to another, and she finally just let her, what's it called, that you have with the software? Yeah, but she let her license lapse because she was just using R constantly. So you can do things like just 2 plus 3 and run that, and it's going to give you 5. So you can use it as a calculator. But right here, we've got, oh, that's the other thing, packages that come, almost every package comes with, well, they all come with documentation, but most of them come with sample data too. So if you just want some sample data to work on, most of the packages have that. This one is about cars, and here is, I already read this. Here is the data. And, oops. So, actually there's more than that. I just don't have this window out wide enough. So there's all these cars, and then there are these variables: MPG, cylinder, displacement. I don't know a lot about cars, but I know all of this stuff. So right here, they're looking at the relationship between miles per gallon and and horsepower and something else, weight. So they run that, and here is the output from that. But this is the same thing. We run these. This one, we take the output and we put it into X, and then we plot X over here. Here's your plotting window. And then we do a regression line through it. You can zoom that plot. So that's
So the commands that you're giving it, once you've designated what the data is, commands that you're giving it simply perform a whole bunch of functions on that data for you, and that includes the visualization. So.
right. And here, like I was saying earlier, if you really wanted to see what the linear modeling or LM function was doing, if you just, well, you can type it there. This is where you code. This window is where you code. This is where you see the results. But there, I just typed in LM by itself, and here's the code for the linear model. So if you're really interested in what you're doing and so forth, you can see it right here.
Is that the actual source?
Yes. Okay. But we've only gotten through the visualization part. Okay, so the next really important thing, what I like, is simulation. And I wanted to start that out with a little story. So there was a physicist, a physical science professor, a chemistry professor, and a statistics professor, and they were working on a project together. And while they were working, they noticed that a trash can in the room caught on fire. So each one of them had their own solution. This was the physical science professor's solution. This was the chemistry professor's solution. And they were arguing about how they were going to put that fire out. And they noticed that the statistics professor was running around and he was lighting all kinds of trash cans on fire. And so they said, "What are you doing?" And he said, "I'm just trying to get an adequate sample size." But this points out the use of simulations, because there's a lot of things that sometimes you have a hard time getting data for. And it's nice to be able to simulate your own data to run different tests and so forth on. I've done a little bit of that with Dr. Sudweek's. Simulated some data for,
She's done quite a bit.
what was the regression one?
It's in for regression and also done some psychometrics. So
And we were looking at doing it for the EFA, exploratory factor analysis. So it's easy to simulate data. There's for a lot of different kinds of distributions. I won't go into all this. There's a lot of distributions. Those are all of them, or there's a lot of them. But what I wanted to show you is something that, and this shows one
this
other.
is one that Mary has made.
So. Also, about 2-3 weeks ago, there was a package that came out. It's called Shiny, and it makes it really easy for you to make point-and-click interfaces front end to your R backend. And so I wanted to try it out. So just yesterday, mostly, I worked on this. And this is about sampling distributions. So this is kind of just a quick thing. So I don't have the interface all exactly right, but it was really easy. Now I have to do all of this. All of what's going on behind the scenes is R code. So this is just an interface slapped on top of it. So we want to explore sampling distributions. So here's a normal one. You could also do a log normal, uniform, binomial. Let's go back up here. Let's say that you have, you want to look at maybe a test that has a mean of 65 and a standard deviation, something like that. And so here's your So here's your population. This graphs the median and the mean. And again, this is not something that was already written. I used little pieces of R code and put the interface on top of it. You can change the bins. I made it so you can change the bins of the frequency distribution or the probability distribution. You can also show individual observations below that. I don't know how well you can see that, if you see density. And you can show a density estimate. And you can so change how much it's smoothing. You can't tell a whole lot on this, but on other things it changes it a lot. Okay, so you can change the population size. So you can make the population size bigger. So here's your population. I set it at whatever, 2,770. And now let's specify, also here's the summary of that population. And here is a table. So here are all these X values. What did I say? 2,770. Scroll down. There's your 2,770. So now let's do some sampling from that population. You can set the sampling size. You can, let's just see it. Here's the plot of the sample. And you can say whether you want to examine the means or the medians. You can see the difference it makes, the number of repetitions, or the sample size. And notice that if you go back to the population plot, see that goes from 30 to 90 or so. But now you look at the sampling, that's repeated sampling, right, of this population. And look how it's, so you can tell. And I could make the the X parameters so you could see, or I could even lay it on top of the other one. But you can see that it's much more narrow. It goes from like 63.5 to 66. So, and the medians are similar. The variances, however, you can see that they're more spread out. And the more repetitions you do, see the mean now is between 64 and 66, most of it. Anyway, this is just a front end that I put onto the back of it, and it's just really surprising me. I did most of this yesterday. It was really, really easy to do. Okay, I won't say really, really easy, but it's fairly easy to do. This last point is the one that I think we should all really be interested in, is the reproducible research. And it doesn't matter whether you're cleaning your data, or you're analyzing your data, or you're reporting your data, you should be able to reproduce it for one, and others should be able to reproduce it. And so let's say that, I don't know how many of you work with data, but cleaning is a big, huge thing. So if you're doing the same thing in cleaning your data, you can put it all now in code. So if you want to check for missing data, or if you want to clean it depending upon how your data is in any other way. For example, we got testing data over the years. There were a lot of things we did to it just automatically. We weren't using R at the time, but I wish we had been, because I could have automated that process. When you analyze something, you can use the R scripts. You can actually even package up the whole environment that you used and save it on, so that when you go back to it 2 years afterwards, which I'm trying to do right now, some stuff, but it wasn't done in R, and so it's really a pain. But here on out, I'm doing things in R, so I can reproduce them. Also, in reporting, I don't know if you've heard of LaTeX. It's basically a markup language. And markup languages, how many know what a markup language is? So there's like HTML, XML. The nice thing about markup languages is they separate the content from the structure and the presentation, which is really great. So that's kind of what, and the reason it's great is you can change the structure, or you can change the presentation, put your stuff back together, and it still works, right? Whereas Word, it's all like this. So if you're trying to change the structure or the content, you can't separate them out. It's the layers idea. Okay, so let's look at this reporting example. Go back to my R. Okay. Here is just a really brief data that I thought I'd put together. So we could have hands raised, and we could say, so how many students are here? 1, 2, 3, 4, 5, 6, 7, 8. I'm just estimating. Oh, 2, that's pretty good. Okay, so let's pretend that these were the ones that I marked for what your interests are in. This is reporting, visualization, statistics, or STEM subjects. You all know what STEM is, right? Science, technology, engineering, math. Okay. And then maybe we have a student representative, a faculty representative, and a non-student, non-faculty representative. Okay. So I've got this report, and I've written it in LaTeX, which is a markup language. And this is all interface in R Studio or R. And I'm going to change this to manuscript. Okay, so I'm going to compile the PDF. it's in APA 6. But I put some, okay, of the 4 faculty, let's see, were there 4? Yep. 2 were interested in visualization, and 1 were, oh, that's the problem. Didn't think about that. STEM topics. Faculty representative Larry, so forth and so on. Results. Oh, I have a graph in there, so kind of look at that graph. It's a random one. It changes every time. I want you to see how easy it is to change your data and change your reporting. So, here it is. 15 people attended. Yep, 15 people attended. So now let's change this. Let's say our data changed, right? So let's make this Voldemort. Let's say there's 5, add 3 here. Oh, maybe it should have been Dumbledore, huh? Not Voldemort. Okay. So you can see that let's change this to 8. So let me save this out. Yes. And now I'm going to try something. I haven't tried this before. I think I can still leave this open and recompile. We'll find out. So let's close this down. Go back to my R environment, and now I'm just going to recompile this PDF. Oh, we had just 17 people attend. That's changed, right? Here's Voldemort. The faculty, 2 were interested in visualization. It might be interesting to note that this many % of the students were interested in visualization. So you can, would that be nice to have? I mean, usually you have a Word document, you're reporting your research, one thing in your data changes, what do you have to do? Go back, rerun the analysis, cut and paste, or whatever. So this is really great. And this next thing that I'm going to show you is probably going to... So now let's say, okay, your manuscript was accepted, but let's make a journal article out of it. So that's all we do is change from man to journal, compile the PDF. And here you have it in the... Now this isn't R specifically, it has the interface, R has an interface to this, and you can do it right in that. But it's based all on LaTeX, which is a markup language, and it lets you do math markup, you can do mathematical symbols and equations and so forth, as deep and as complex as you want to get. You can size them. So you can see, here we have again, the same. And this is actually code. You can probably tell that graph changed automatically, I would say. And then here is actually where that should match this perfectly. Because it's just printing out that. So, anybody excited yet? Okay, but wait, there's more. Besides being great for anybody who's interested in STEM, including teaching STEM students, they should all be aware of R. 1, because it's free. 2, because it introduces them in a kind of gentle way to programming concepts. There's sample data sets. There's, if you're interested in machine learning and data mining, which I am, there's interfaces to Hadoop and Weka. I don't know if any of you have used those. The open community, of course, it is an open community. There's packages for text analysis, including the word clouds that everybody likes, but there's a lot more than just the word clouds. There's packages that do automatic generation of tests and test items from a database of items. You can output the output from R as HTML, as a PDF, or as LaTeX. And if you ask now, there's free digital books for BYU students. So on BYU's online collection, there's multiple books that teach you how to use R. Some of them are really good. Actually, most of the ones I've looked at are good. And inclusive of the R for Dummies. In fact, the class that we'll be teaching, we are not going to have a required text because you can find, there are so many free texts, why should we? This is just a New York Times article, and this is something that Jared, who was supposed to be here at this presentation, but he's at a conference, and he's going to be co-teaching with me. He found on the Colorado Department of Education, there was a job that was listed at $70K a year, and the main requirement is to know how to manage databases in R and analyze data in R. If you can use R, that is a great job skill too. And these are some different quotes. This is from Mr., I don't know how you say his name, I call it IHACA because I think it's great to have a programming environment built by IHACA, right? He said, but it's a real demonstration of the power of collaboration, and it really is, because so much is contributed free and open from people who are doing that research. And he said, you know, we could have chosen to be commercial, and we would have sold 5 copies of software. He's probably right. It probably wouldn't have been near as good either. Can one be a good data analyst without being a half-good programmer? The short answer to that is no. The long answer to that is no. And then this is what is really, when you understand this, you see the beauty of R, is that there's so many things you can do, but there's so much prepackaged stuff that you really are standing on the shoulders of giants. Google uses it. They don't use it for their huge amounts of data because it's not real great for, and when I say huge amounts, probably a lot more than you'll ever be looking at here in this program unless you're doing like terabytes. But they use it to do the small stuff, get it right, and then they use the other bigger things like Hadoop and so forth. But scientists at Google do use it. And then the one that I had, the quote that I had up from the beginning, which is about, we teach kids how to use software, but not how to write software. And so that they have access to the capabilities that others have given them, but they don't have the power to determine the using those capabilities and making technologies for themselves. And I think that is going to change, or at least it, when it does change, that's when progress in so many areas will just take off. So, back to the beginning, if the world is our campus, which would you choose? Don't get stuck on the bus. However, you can still ride the bus whenever you really want to if you have the money for the fare. So you're not eliminating that option. So, questions? Or just anything you want to see?
For your class, what level of staff would you recommend that people are taking the class?
I can tell you what I would answer. I would answer that that's not the important determining factor, that you'll probably be exposed to some statistical stuff just because you'll be doing it, but don't feel like if you haven't had anything that you can't take the class. The class will also be project-based, and so whatever your interest is, if you wanted to learn more about that interface, you know, that I showed you with the point and click, maybe that's your project. The other thing is, for any of the faculty, we would like to, if there are faculty that think they might have a small piece of real analysis that they'd like some students to do, we'd like to give them an opportunity to present that and let the students see if that's something they'd like to do, because I think it's a lot more instructive to give a real, use real data and work on a real project rather than one that they'll make up for themselves. So any of your faculty members, if you have any piece of data that you'd like to know if it could be done in R or what we could do. Another thing about the class that I really would like to do, we'll see how this goes, I would like each student to teach somebody else about R, because it's in the teaching that you really learn. And so maybe part of that would be, okay, go home today, and even if it's your child, spouse, friend, whatever, that's not a programmer, that's not statistically inclined, I want you to teach some certain concepts to them. And I think you'll be amazed at how easy it is to learn.
Is it possible to integrate R with well, for with websites, for instance? So I'm doing this learning analytics thing for my job. This program we're working on, we use a JavaScript library for statistics, but it's kind of not built for that.
Exactly. So the interface that I showed you, this runs from a browser. This is a browser. I'm using it as a local host, but if you can put it on a server and run it from there. You can actually put your code on GitHub. I don't know if you know about that. And run it from there. So you can put it on a website, you can embed it, so yeah. And that's what I love about it.
Other scripts from other languages and stuff, easily?
There's almost always an interface to something. I'm not sure, I don't know a lot, I'm kind of trying to get it to work with JavaScript per se. I know that this interface, but I know it does because this interface uses JavaScript. So I know there's a way to do it. I like a quote that somebody made, a Yoda-like quote that said, "This is R. There is no can, only how." Anybody else? We'd love to have you in class if you're the least bit interested. Come and see what it's like. Sit in. My main objective in the class is not for people to leave going, "Oh, yeah, now I know about R. I don't think I want to do that again." My main objective for the class is, wow, I know how to do this, and not only do I know how to do this, but I know how to find out how to do A, B, C, and D. So the objective is really to leave the class being excited about what you can do and wanting to do more.
Just say thank you.
How are you planning on using this in your study?
I am interested in analytics, and so one of the things with analytics, and also actually it's as analytics as they inform instructional design, because there's so much educational software out there, and yet we're not looking at the data that's coming back that we get for free because it's online. And so there's a lot of reasons for that. Some of the reasons are a lot of the research that's been done on that is not cognitively accessible to your average educator. I think that can change. Another reason is a lot of the data, especially K through 12 data, has privacy issues. So one of the things that I'm very interested in doing is, can you take a set of data and simulate another set of data that has all those qualities, but it's not that data, so you're divorced from the privacy issues, but you can still use the data. So that's what I want to do. So let's say that a school has a lot of data about a particular whatever it is, whether it's a software package, an LMS, whatever. Can you take that data, take the parameters of it, and then simulate other data that for those parameters for those particular parameters you're looking at matches that, and then you can do whatever you want with it. And then, as a sidelight for that, this is what I'm really interested in. The reason you have to do that is so I can do this other thing, which is how do you make all this data, this big, huge, we have so much data, how do you make it consumable by the educator to say, oh, wow, I see from this data that. So what I'd like to do is once I can simulate data, I'd like to say what visualizations for this data make it easiest for teachers to find actionable items or find knowledge about the software, the learning management system, their test, whatever. What visualization makes it easy to see? Oh, there's one visualization I didn't show you. This will kind of blow you away, maybe. So this is something that JavaScript I know is helping with it, but it's a package. It's called Google Viz. It's run from R. I don't know if you've seen this before. Have you seen the motion charts from Hans Rosling and I can't remember the stuff he did. Anyway, you can access this, so you can set up, for instance, here I have sales. This is just a fruit database. They have sales, time, across time, 2008, 2009, expenses. So you have multiple, it's not just your two-dimensional graph, right? So you can see what it does over time. So what if you had this going for students, right? You could see across time what happened. Maybe in the middle of the semester, boom, the scores went like that. Or maybe everybody else is going this way, but you see one student going down like this. Some things you can see better when you see them over time. So, and that's all done from R.
So like real-time recommendations, or so this is a visualization, for the data that the program's generating, but would you also do that with R? So
The real-time stuff?
Like a real-time recommendation. Based on the
As
current
long as
state
you
of
have the
data.
data back, right? Yeah, because you can automate all of that, but you do have to have the data.
So in that case, does R run concurrently, could it run concurrently with, say, an instructional event of some kind? And could data be swapped between them? I think the question that he's asking has to do with, can R be used as not only a data analysis tool, but can it feed the data real time back to the application?
Well, you saw, this is a really small example, but you saw that I did that with the Excel chart, right? As soon as I updated it, it was available in here. Now that's a little bit different than getting data from a server. So that would have to be worked out, but there's no reason why you couldn't. There's not a package for that probably yet, but maybe there is.
So you can't have external data then?
Oh, yeah, you
All the
can
data has
have-
to be in R?
You can have external data. I mean, you have to read at least a portion of it in, right?
But it doesn't have to be housed in R,
Oh,
or does it?
There's
No,
not,
the cars was coming from outside.
well, the cars is a data set that actually
There's
is
no-
in there.
there's no interface that lets
Right.
R communicate with other interfaces.
Yeah, there is. I know that there's an interface to use with Weka. And I know that there's interfaces with a lot of things. I mean, that the thing that I showed you with the distributions, right? The part that talks to the browser, it's updating that to the browser all the time, so there is communication going on there.
How does R compare to other statistical packages that's hardcore statisticians would use SAS or?
The hardcore statisticians use R.
I took an applied nonlinear correlation class, which I was totally unsuited to take, from the statistics department in graduate school. and this is what they used. This is to make some really, this is what they used to make really advanced models of things. Yeah.
Originally,
MATLAB.
R was originally created as S+ language that the statisticians used. And they tried to sell it S+. And the developers came along and changed it to R. So it's all free now.
In fact,
This is what the statisticians use.
the guy that wrote S, the guy that created S, his name's John Chambers, he worked at Bell Labs when he did that. And then these other two people, the IHACA guy and Robert Gentleman, they made R from that. And the interesting thing is that the core team now that develops and maintains the R environment, Chambers is a part of that, that core team, which I think is really interesting. So, yeah, I would say probably anything that you're going to do in a first or second semester statistics class can easily be done in R. In fact, there's a lot of times that, when we were working on that simulation, we wanted to test and see, what were you using?
SPSS.
Yeah, he was using SPSS and I was using R, and I said, okay, let's see who gets it first. And I was like, I ran one line, done. He's flicking and pointing. So.
What about versioning? Does it track your changes over time?
You can set up versioning. I haven't looked into that, but I know
It works, it says our studio works with like Git and subversions.
Yeah, yeah.
So,
I haven't done that personally, but I do know that you can do that.
Can we continue the question and answer down
Absolutely.
down the soup kitchen?
Thanks for your interest.
Thank you, Mary.